Okay, so let's go ahead and start today's lesson. Alright, so today's lesson 12.2, day 1. We'll talk about, yesterday we had a lesson in 8th and 9th, so I recorded that one, so this is going to be one you're going to be expected to go online and look at and fill out and know for the test. I can talk about at the end of class how you're going to access that. Yeah, so what I'm going to try to do is kind of make a tracker for you all, because I know this can get kind of confusing with testing what class am I supposed to do, what not. So I'm going to make like a tracker for you next week so you can kind of check, okay, have I heard this lecture, I've either seen it or watched it online, and this homework is due. We'll talk about all that at the end. But for today, this is good class week. So, let's look at lesson 12.2, day 2. So if we look at this limit, as x approaches 4, x squared minus 6x plus 3, we approach x 4 from both the left and the right. We approach x as 4 from both the left and the right. And so when we approach x 4, what do we get? What do we approach in the f of x?
Negative 5.
Negative 5, right? It looks like both sides get closer and closer to negative 5. But one thing you might have noticed, and the thing we're going to do today is, you really don't have to do that table every time, right? That's just kind of an exercise to get you to think what exactly is going on with the limit, or about the concept of the limit. What you can do to figure out what it is at 5 is just plug in that 4, right? So if we do that here, we do the calculation, and we get that when you plug in 4, you get negative 5. And so that's what we're going to do today, is that on tests and on your homeworks, and really just in calculus in general, you're really just going to plug in the limit to see where the limit goes to. Again, the table is just kind of a thought exercise. All right, let's turn the page here. Give me 1 second.
Yes, sir, Coach.
Got to plug this in. Sometimes it'll not cooperate if you don't. All right, so let's look at some examples here. Let's look at some examples. So, particularly, let's look at this one. Say, example A is going to be the limit as x approaches 2 of negative x cubed plus 4. So x as it goes to 2 of negative x cubed plus 4, right? Alright, so what do we want to do here? We just want to do what?
Plug in the 2.
Let's just plug in the negative 2, or the 2. So we say minus 2 cubed plus 4 is going to be equal to, anybody know what 2 cubed is? 8. So negative 8 plus 4, and of course we know that as negative 4, right? Pretty simple, right? Nothing too complicated, you're just plugging in, right? It's just like you're plugging in the number 4 function. Let's do a few more just so you can kind of get the idea, also to kind of see a few different ways this might look. So this time let's take the limit as x approaches negative 2 of 4x cubed plus 1 over x minus 5. So let's see what happens there. Alright, so what do? We plug it in. So we're going to get 4 times negative 2 to the 3rd power plus 1 all over negative 2 minus 5. Right? Alright, so negative 2 cubed, is that going to be negative or positive?
Negative.
It's going to be negative, right? Because remember, whenever you have an odd exponent, you keep the sign, right? It's either negative or positive. With an even exponent, it's always going to be
Positive.
positive, right? Because you're squaring it. Like negative 2 squared is the same thing as 2 squared, which is 4. All right, so 4, negative 3, that's going to be negative 8 plus 1 over negative 7. And this is just arithmetic, right? You just add some, so negative 32 plus 1 over negative 7. Negative 31 over negative 7. And of course, 2 negatives on top and bottom give you a positive. So you get 31 over 7. 31 over 7.
So we could just put fx equals and then 31 over 7, right?
It's not fx is equal to, it's that this function, as it approaches x at negative 2,
Fx
is equal to...
approaches?
What?
Fx approaches 31 over 7?
No, as x approaches negative 2, f of x, or the function, approaches 31 over 7. Yeah.
That's, yeah.
Okay?
Yes, sir, coach.
What? Yeah. It's recording.
All
Alright. You got it?
yeah.
Okay.
Yes, sir.
Any other questions? Let's look at C. Let's look at one more. So I'm doing this one because a few people get intimidated by some large numbers. So the limit as x approaches 4 of x cubed minus 3x squared minus 5x plus 7. So people might get intimidated by a problem like this, right? Because it has some huge, like, squares, right? But there's really nothing to be intimidated by because you just do what you did in the other ones, which was what?
Plug it in.
Yeah, let's just plug it in. So we have 4 cubed minus 4 squared minus 5 times 4 plus 7. And yeah, we could do mental math, but we have our calculators to do this for us, right? And so you punch that in the calculator and you get 3, right? Right, you get 3, yes. So that's all we're doing. That's how you evaluate limits, is you literally just plug in the value, and there it is. All right. So any questions on this?
No. No, sir, coach. Bob.
All right, everyone. Let's go ahead and do some independent practice. So go ahead and turn the page, and you'll see a U-try that has 3 example problems. I've written an answer key up here, so if you finish a little early, you can kind of check your work. Go ahead and take about 3 minutes to do that. 3 minutes. What does he do to go like this?
You know me and Alex, you know Alex and Alex. You know Alex and Alex, the basketball player. Well, we have 8th period of athletics and his basketball clubbing, and we pretended we were fighting, and she was freaking out. And I was like, stop.
Should I come out in the video?
Huh? Yeah.
Sorry.
Sorry, Miss Passman.
What if like you get famous because of the videos and just like you hear our stuff in the background?
Then I'll see y'all later. And, from the connection. I highly doubt that's gonna happen.
Same.
So you know that guy Khan from Khan Academy?
Mm-hmm.
He has like 20, like he went to MIT, got a degree in like computer science or something. Then he has his MBA. And then I'm pretty sure he has like some sort of medical degree too. And so all he does, like, so he decided he just wanted to make that website. And yeah, he makes like a lot of money because Bill Gates like funds it. So.
What? Bill Gates funds it?
Partially.
I put speaker on me right now.
So we'll put something in.
I can turn it on right now.
Like,
No, you.
hey, what was that?
My phone.
we could have done this at first, right? We could just plug it into the, but instead you wanted us to make the chart so that we could see how it approaches.
Yeah, that's what I want, just so you can kind of get the idea of what's happening.
Starting to register here now. That's all. Wait, so it's recording everything that's on there? Like, so if I put my face under there, my face is gonna come out?
Your face will come out there.
Try and do it, try and do it.
Nope. Alright, let's get started. So, let's look at the first one. So the first one's kind of interesting, because if I take -1 to different powers, right, so let's think about this. So 1 to any power is always what?
1.
1, right? 1 to like the 11th power is 1. What about -1 to what? It's either 1 or -1 depending on what?
If it's even or odd.
Yeah, if it's even or odd, right? So it kind of switches here, right? So you can kind of do some mental math. This is just stays -1 because that negative becomes positive. This becomes negative because that -1 to the third is negative. And then this -1 squared becomes negative, so it's just -2. And then just -1 plus 4, you do that, you get -7. Simple enough, right? For B, you plug in -5, so -5 plus 1 is -4. Over -5 squared plus 3 gives you -4 over 28. That's something that you should know how to reduce that, right? We should all know how to reduce that, and that gives us -1 over 7. Let's look at this last problem. So, we put in, so we're going to plug in 1 because x is approaching 1. We get 1 squared minus 1 over 1 minus 1. Now, of course, 1 squared minus 1 is just 0, and of course 1 minus 1 is also 0. So that's a little strange, right? So what's wrong here?
There's a 0 under it.
There's a 0 in the denominator, right? We see that. But there's also 0 where? In the top or the numerator, right? So that's the key distinction. If it was like 3 or 4 or 5 over 0, yes, that would be violating something and the limit wouldn't exist there, or it could shoot off to infinity. But in this case, it's 0 over 0. And whenever we see that case, we say that that is what we call indeterminate. We call that indeterminate form.
Would you say undefined?
No, we cannot say undefined. And I'm going to tell you why in a second.
Why'd you take my pictures down?
Because people got mad
Which people?
by the school leadership.
Ah, I hate this school, don't you, Mr. Locke?
So,
No one could take a joke from me.
definition. So, I went up and I looked up the definition of indeterminate, right? Just if I were to use the word indeterminate in everyday language. And what it said was not exactly known or defined, right? So, indeterminate means not exactly known or defined, right? So for instance, your grade at the end of the 6 weeks. You have an idea of what your grade will be, but do you actually know what your grade is going to be at the end of the 6 weeks?
Sometimes.
Does anyone know at this moment? No, it's indeterminate, right? You're not sure what your grade is going to be yet. Again, you have an idea what your grade is going to be based on your past grades and how you're doing this semester, but it's not yet determined, right? Same exact sort of case when you get an indeterminate form. What this is basically saying is that, so this limit could exist, so this limit could exist, or it might not. Right? So whenever we get something that's 0 over 0, when we plug in the terms of the limit or what it's approaching, that's basically saying we don't know if it's going to approach it or not. We don't know whether or not it's going to exist. So what we have to do is we have to investigate a little further, do a little bit more math to determine whether or not it will indeed exist.
So nobody has solved that yet, right?
What's that?
So nobody has solved that yet.
Solved what?
I mean, that's indeterminate.
No, we're about to see how you do it.
Oh.
How do you determine whether or not it exists or not? Okay?
Okay.
Let's turn the page.
Oh.
Let's turn the page and let's talk about finding out stuff that's in indeterminate form. So indeterminate form. Alright, so when something's in indeterminate form. Alright, so let's look at this example. Let's say that the limit as x approaches -4 is going to be x squared minus x minus 20 over x plus 4, right? It's a fairly simple problem. So again, what do we want to do here if we're trying to find this? We do what?
Xbox.
Not Xbox.
Plug it in.
Let's plug it in, right? So let's see what happens when we plug it in. We get -4 squared minus -4 minus 20 over -4 plus 4.
0 at the bottom.
Yes, well,
And
let's look at the top, right? So -4 squared is 16. Minus 4 is going to be
4.
positive 4 and minus 20.
0.
All over -4 plus 4. Right, I'm just leaving it like that for a reason. Because 16 plus 4 minus 20 is
0.
0. What about -4 plus 4?
I guess 0.
Also 0. So this term is what we know is indeterminate form, right? We don't know whether or not this limit exists. We have to think about it. We have to do some stuff to it. Now, how can we find out, right? How do we know whether or not this limit exists? How can we find out, right? Well, we think back to Miss Lee or Miss Legette or Miss Sorrell or Miss Vaughn or whoever you had, right? Whoever you had. And so we're going to use algebra, right? We're going to use algebra to figure this out. More specifically, we're going to use factoring, okay? And let me say right now that if you plan on going into calculus or any math class over this, factoring is going to be a big thing, right? One of the things frequently in calculus that people struggle with is the factoring, right? Being able to simplify things, being able to pull out terms to be able to kind of simplify things. So factoring is definitely one of the biggest concepts that we're going to need to explore. Alright, so let's press the rewind button and let's go look back at this. So let's rewrite it. X minus 20. Okay, so we rewrote this problem. What do you notice
The quadratic
about the top here? What did you say, Dario?
quadratic equation.
It is a quadratic equation, exactly.
So smart.
It's a quadratic equation, and so, what do you use in that case?
You do the x.
Do the x box. You use x box in this case, right? Alright, so let's do that. So we'll say, so what goes in the top?
-20.
-20. What about the bottom?
-1.
-1. Good. And so, okay, what two numbers will multiply to -20 but add to -1?
-5 times 4.
-5 times 4, right? Okay. So that means we're going to rewrite this limit.
Which is x.
We're going to rewrite this limit. Come on. We're going to say the limit as x approaches negative 4 of x plus 4 x minus 5 over x plus 4.
I thought it switched, so like I thought when it said negative 5, you just switch it to positive 5.
No, you don't switch it. You just keep
That
it.
just means equal to positive 5.
Oh, okay.
So, Gershon, what do you notice here?
Next plus 4 up and bottom.
Yeah, there's x plus 4. And so what does that mean? You can do what?
You can cut them out.
Yeah, they cancel, right? Those go to 1 because anything over itself is just 1. And so that gives us the limit as x approaches negative 4 of x minus 5. Now we can do what?
Just plug it in.
Just plug it in. Good. Negative 4 minus 5 is negative 9.
You got 5.
And so, if you were to do the table and kind of see where this is approaching as x gets closer and closer to negative 4, you would still see this. You would still see that both of those would approach negative 9, even if you used this original equation that, as we saw, gave us an indeterminate form. All right. Let's do one more example. Let's do one more example.
Oh.
Let's look at this. Let's say that the limit of x as it approaches 0 of x squared plus x over x cubed plus x squared plus x. Okay.
It approaches 0.
So let's look at that. So this should be pretty obvious. When I plug 0 in, what happens?
Undefined or undetermined.
Indeterminate. Everything goes to 0, right? So it's 0 squared plus 0 over 0 cubed plus 0 squared plus 0, right? Which is 0 over 0.
Oh, duh.
Right? It's 0, 0. That's an indeterminate form. So we have to go back and kind of look at this and rethink our strategy. Let's say, okay, so the limit as x approaches 0. How can we maybe factor this? Do we notice anything about the top and bottom? Do they have any common factors?
X squared and x.
Not x squared, but x, right? We can factor out an x, both out of the top and bottom. So, for instance, in the top, we can factor out an x. When I factor that x out, that x squared becomes just x, and this x just becomes 1. Okay. In the bottom, x, factor out an x, x cubed becomes x squared. X squared becomes plain old x, and x becomes 1. Okay. So then what happens to the x's on top and bottom? They cancel, right? Cancel. And we're left with the limit as x approaches 0 of x plus 1 over x squared plus x plus 1. So when I plug in 0 for the x's, what's going to end up happening?
1 over 1.
Is it a 0 plus 1, which is 1?
Yeah, all anything with the x is just going to go away, right?
Mm-hmm.
So we're just going to be left with these two 1s here, so it'll just be 1 over 1, which of course is just
1.
1. Okay? So that is the magic trick. Okay. Any questions?
No, sir.
Okay, go ahead and turn to the next page.
3 fans.
Go ahead and try those 3 problems. Go ahead and try those 3 problems. I'll give you about, it takes a little bit longer of a process. I'll give you about, take about 4 minutes to do this.
So we just factor out into x, right?
Did you factor on the top?
Can you do a voiceover?
Like the beep?
Yeah.
No, I don't know if I can.
We should figure out a way.
Would I really want a beep in my video?
Do like the little nuclear sound, like you know, when it interrupts like with the television. We should do that. I mean, school has terrible connection.
True. FYI.
Like, oh,
So we'll go
live.
top.
I'm gonna go put my face under there.
You're getting the number right? Yeah. Negative 36. What about the bottom? It's the number that's attached to the x term. Not the x squared term, but just the x term. Right? So that do you see an x? No. Do you see an x there? It's just an x. No. So that means that the x has a remember there, it's just it's nothing. So it's 0, right? Because there's nothing there. So can you think of two numbers that multiply to get negative 36, but add to get 0? What two numbers would multiply to get 36? Negative 36, but add to get 0.
Alright, so let's go ahead and look at these. Some good work done here. Alright, so here are the solutions. So in the first one, as you can see, if you plug in negative 6 at the top here, if you plug in negative 6, you get minus 36, negative 6, you get 0 over 0. Now, the top you can factor one of two ways. Either you can use Xbox and say, okay, negative 36. Now, what I was pointing out to people is that the bottom number is the number that's attached to only the x term, right? The number with only x in it. Now, because there is none up here, that means that we have to have a 0 down here. So that means that we have to figure out a number that when I multiply, I get negative 36. When I add, I get 0, which is what? 6 and negative 6, yes. So that means that it's going to factor in the x minus 6, x plus 6. Now, one other thing you could do that maybe you learned in algebra but maybe forgot was what's called difference of squares. Basically what that says, if you see a squared minus some b squared, you're can break it up into a minus b, a plus b. So it kind of just skips the x box here. It's kind of an extra, like just a little shortcut you could take to get here a little quicker. So anyway, the x plus 6's cancel. So you're just left with x minus 6. And you plug in the negative 6, you can get negative 12. 2 is a little simpler. You just got an x box at the top, just negative 6 over 1, got negative 3 and 2. X minus 3 cancels out. You're left with x plus 2, which is equal to 5. Last but not least, you have the limit as x approaches 0 of this big, scary function. Now again, you had to figure out what common factor the numerator and the denominator have. So what common factor did they have?
3.
Not 3. What? X cubed, right? X cubed, or x to the third power. Right? So you take the limit as x goes to 0, pull out the x cubes on both. That leaves you with x cubed minus 1 and x to the 11th power minus 1. And so the x cubes cancel. You get this, plug in the zeros for the limit, and you get negative 1 over negative 1, which gives you 1. Which gives you 1. Alright, so any questions about that? Any questions at all?
No.
Alright. Cool. So let's look at the homework really quickly. So that is it. So a few things about this. First of all, we got a lot of stuff going on, right? We have AP testing, we have end of year exams. And again, like I mentioned to you, there's going to be some lectures that you might miss that you need to catch up on, right? So what I'm going to do is on Monday, I'm going to make a tracker. I'm going to make a tracker over the weekend, and I'm going to give everybody one. And what it's going to be is it's going to kind of track your progress so that you know that you've got every lesson and that you have every homework assignment, okay? So like, I know it can get kind of confusing. So if you have that, you can keep track of it. As for homeworks from here on out, so again, you have that homework due today that I assigned earlier in the week. But on the May, so what's going to happen is we're going to have next week is going to be our last part of this unit. Then on May 16th, the homeworks are going to be due. So all of the homeworks from here on out. So so the one we did yesterday, we'll talk about that, is due, as well as this one, and any homeworks from next week will be due the Monday after, so the 16th. Now, this day is also going to be your unit test. Now, again, it's a Monday, and I know we don't like doing that, but the thing is that senior signing day is the next day. And my guess is a lot of seniors and even juniors probably don't want to go into senior signing day and they have to come back and take a test. My guess is y'all don't want to do that, right? It's probably a bad idea.
Yeah.
So let's just get it over with that Monday so we can kind of just distress and relax during senior signing day and then shoot right back into review once we get back that next day. Also, so yesterday we did have a lecture. Here, let me just stop this. All right, goodbye everyone for today's lecture. You had a good time.